Photons and electrons are surrounding us all the time, but have you ever thought about applying them in the field of biomedical engineering? In that way, we have biophotonic and bioelectronic. Biophotonics is the use of manipulation and detection of a photon, a quantum unit of light, to enhance our understanding of biological processes and functions. Optogenetics is one of the examples. It uses light to control the function of specific cells. For example, it uses light to control the pathway for ion channels. Normally, these ion channels are activated by specific molecules such as neurotransmitters to open for influx of ions and generate electrical current. In this case, we can use light to open the ion channels. We can also simply control this process to the target cells by using fiber optic wires. Because of the optogenetics, scientists are able to get fast and accurate signals and use this to figure out how cells work or treat diseases. Have you guys ever heard about Alzheimer's disease before? It is a common disease among the aged and is difficult in diagnosis until a relatively severe symptom has developed. In 2017, with fluorescence spectroscopy, we can diagnose Alzheimer's disease accurately. This label-free optical spectroscopy can act as a biomarking process for Alzheimer's disease. Fluorescence spectroscopy demonstrates an effective optical method for measuring fluorophore composition differences between Alzheimer's infected tissue and normal brain tissue, and for detecting early-stage Alzheimer's disease by comparing spectral profiles.
Now, let's talk about bioelectronics. Bioelectronics is the application of the principles of electronics to biology and medicine, such as artificial limbs and humanoids. Wearable electronics, such as smartwatches, are familiar to us nowadays. Almost all of them have the heart rate measuring function and act as an example of bioelectronics. Let's take Apple Watch as an example. The heart rate sensor uses infrared light to measure the heart rate of users, calculating the walking average and heart rate variability using the photoplethysmography technology. Besides, bioelectronic medicine is a paradigm shift from existing medicine. Instead of treating patients by intervening drugs and chemicals in their bloodstream, they treat patients by interacting with their nervous system. Bioelectronic medicine can read and write signaling patterns and pass it through bundles of axons of the target organ. Through such precision, we believe these bioelectronic medicines will not only be a new avenue for treating diseases, but they will have a greater therapeutic benefits and fewer side effects as well.
Though introduced as two categories, biophotonics and bioelectronics could collaborate under photoelectric effects. Photons could be the inputs or outputs of electronics, like television. And by associating with organic system, we may control ion channels rather than TV channels. But of course, the specificity of the characteristic photons, the design, and fabrication of the electronics ought to be further investigated.
Although biophotonic and bioelectronic technology are still young in their development in the field of biomedical engineering, we can expect a rise of both fields in the future market. By applying these technologies, we can approach healthcare differently, and humans can anticipate the future of treatment to be highly effective.
Thank you for watching this video. Bye bye!